Hello students. Today let's talk about how Robert Millikan and Harvey Fletcher experimented on determining the charge of an electron. Before this, J.J. Thomson already told the world about the existence of an electron inside an atom and that it is negatively charged. He also gave us the specific charge value of it, but wasn't successful in obtaining its charge. This is because it is a tricky thing to do. You can't simply get the electron out of an atom and measure its charge. To do so, some trick must be used, which will possess a very precise balancing of two known quantities. This is what exactly these two scientists, Millikan and Harvey Fletcher, did. They balanced electric and gravitational force to calculate the charge of an electron. As we are clear about how they determined it, let's see the apparatus used by Millikan and one of his graduate student, Harvey Fletcher. They took a pair of parallel horizontal metallic plates where one is anode and another is cathode, creating a chamber-like space where an uniform electric field was created in the intermediate space by applying a potential difference between these two electrodes. As you can see here, there are two holes in this chamber. One was to keep X-ray source and another a microscope to observe the oil droplet. Okay, now from where you are having this oil droplet, a closed chamber with transparent wall was fitted above the plates with an atomizer. So what is an atomizer? An atomizer is just like a perfume spray, but it can spray very tiny droplets. So this was used to make tiny oil droplets. And as you can see here, these two chambers, that is the oil droplet one and the electrode ones, are connected with a hole in the anode plate. Now let's see the working of the experiment. A fine mist of oil droplet was sprayed into the chamber using an atomizer. The oil was so chosen that it had a low vapor pressure and it incorporated the electrons by ionization of gas taken in the another chamber, that is the electrode one, when X-ray was applied or X-ray was emitted in that particular space. Now let's see the actual experiment stepwise. So as you can see here, a mist of oil is collected in the chamber placed above the metallic plates, and through the small hole it entered the space between the electrodes. The X-ray in this space is used to ionize the gas and ejected electrons are adsorbed onto the surface of oil droplet. Now, in absence of discharge, it comes down under the gravity influence, right? Any oil droplet or anything, if it is under gravity, it will come down only, right? Now, if you remember, anode was the electrode which was placed upward, okay? Then, when we apply the discharge, what can happen? There are two possibilities. One is when the drop is hanged in between and doesn't show any movement whatsoever. This is when the electric force applied is equal to the force due to gravity. And another case is when the applied force, that is the electric force, is more than that of force of gravity. At that time, all droplet will be moving upward. Why is it so? This is because it is having absorbed electron onto it, right? And electron are negatively charged. Now, one charged drop is selected which is at the field of view of microscope. Okay, so microscope has a placement, right? So I should select a droplet which is visible through this microscope. Okay, and all other droplets are allowed to fall down by alternatively switching the voltage. And then the experiment was conducted with the help of this drop. At one time, we will be only seeing one of the droplet. Okay. Now, this droplet is suspended between the two plates, implies the two forces are balanced out. What are these two forces? The electric force and the force of gravity. Now, we can write this as Fe is equal to Fg. Now, we already know that E is equal to V by D, where V is the potential applied and D is the distance between two electrodes. Now, let's keep this E value in the equation. We will get Q into V by D is equal to mg. Ultimately, we will get Q value as m into G into D divided by V. So, the charge applied Q was in zeptocoulomb and was found that it was always a multiple of 160. Say for example 160, 320, 1120, 1280, 1440 and likewise. So, these values were actually the multiple of 160. 160 can be written as 1 into 160. 320 can be written as 2 into 160. 1120 is 7 into 160. 1440 is 9 into 160. Thus, from the above explanation, we come to know that the charge obtained here is equal to N into E. Now, what is this E? E is actually the simplest multiple which we are obtaining here, which is 160 zeptocoulomb. It is also the charge of an electron. How he know this? This is because he did the experiment many times and each and every time he was getting Q in the multiple of 160 zeptocoulomb. So, that's why he came to know that the charge on an electron is 160 zeptocoulomb, which can also be written as 1.6 into 10 to the power minus 19 coulomb. But over here, as it is for electron, I will write it as minus 1.6 into 10 to the power minus 19 coulomb. The minus is because it is negatively charged. Okay. So, thanks to the work done by Millikan and Fletcher, we finally have the value of charge of an electron, which is minus 1.6 into 10 to the power minus 19 coulomb. And thanks to the Thomson experiment, E by M experiment to be specific, we have the specific charge value, which is minus 1.76 into 10 to the power 11 coulomb per kg. So, in order to calculate the mass of electron, we can divide the charge of an electron with its specific charge and will get the mass of the electron as 9.1 into 10 to the power minus 28 kg. Okay, so by this experiment, not only Millikan and Fletcher were able to determine the charge of an electron, they were also able to find the mass of an electron using the specific charge.